Hi, it's me, Tim Dodd, the Everyday Astronaut. Welcome to a very special and extremely important live stream. Now, I need you to listen very carefully. If you guys are not listening right now, you're doing some stuff wrong. Here's the deal. You can only watch my stream tonight if you have Rocket Lab's official live stream pulled up somewhere else on another device, or two on one screen, one on a computer and a TV and a tablet or whatever. That is the rule. I will be reminding you of this obnoxiously because tonight every view of the official Rocket Lab live stream will be $1 donated to the, this is a funny name, Starship Children's Hospital. It's always been called Starship. It's a hospital, children's hospital in Auckland, New Zealand. So every one person watching that live stream, that someone will be donating $1. I don't exactly know. I don't know if it's Rocket Lab or who. But so it's really important that we are not taking any viewers away from the official live stream, and that instead we're at least adding to it. So if you don't have both things pulled up, I expect right now to see our number of viewers dropping and to see their number of viewers going up. Please. On top of that, any donation here tonight for the Super Chat will also be given to Children's Hospital, to Starship Children's Hospital. So I have already begun coordinating that with the Rocket Lab people, and we'll have some transparency there about it just to let you guys know that was indeed the case. So thank you in advance. I didn't know what to do about this, but the reason that I'm so excited to stream tonight is because this is the first time they're going to try and recover a booster. So this is a really big step for Rocket Lab. This is something that I've been waiting for since even before they ever announced that they're going to be trying to recover and reuse a booster. I just hope that they would someday look into recoverability, and tonight is the night that they try and recover a booster for the first time. So let's see here, guys. So again, as soon as Rocket Lab is officially up, I do have the link to Rocket Lab in the description. It's also a pinned comment, so you have no excuse to not have both of these babies up. I see some good news right now. They have 14,000 people waiting for their stream. So we're doing good. They officially have more people watching than here. So please abide by that rule. Just you can always watch me later if you want to watch live. The important thing is that we get that count up. That matters. That could be a substantial fund, a substantial amount of money going to a good cause. You know, it's 2020. We can come together on one thing, right? And that's children's hospitals. I mean, come on. So, okay, let's go ahead and read the pre-launch preview for this mission, because I think that's pretty important. So, yeah, anytime you guys have any questions about upcoming anything, you know where to go. You can go to a certain website called everydayastronaut.com, and there you can click on something called pre-launch previews, and you can check out today's mission or any upcoming rocket launch. Today's mission is Return to Sender. Think about that name here. So we have a lot to talk about, and as soon as Rocket Lab's stream is up, we will be talking about that as well. So, okay, let's see here. So, launch window, this is taking off today, November 20th, at least in UTC time and local New Zealand time. It's going to be, 2:44 in the afternoon, or 14,400. Okay, chat. Holy cow. Okay, you guys are, I'm gonna cry. Wow. First off, Jamie, one of the sole people, one of the reasons why I do what I do is because of Jamie Higginbotham. So, holy crap. Oh man. And another, you guys, this is incredible. Okay, there's going to be a lot of transparency here, so you guys know that this money's going to the right place and not just to Tim's Starship Fund, because those are entirely different things. Wow. You guys are amazing. Okay, good. And as long as you guys have both streams up, you're making me happy. As long as both streams are up, you're making me happy. Okay, so let's keep going through these here. I'll try really hard to get through some of these, but tonight we might have to just let a few of them slide. But I'll leave it up to you guys in chat. Thank anyone on behalf of not really me. This isn't anything to do with me. I'm only doing this because I felt really bad that I was potentially in some way going to be hindering Rocket Lab's exposure to this cause. So I figured we can help with that. So thank you on behalf to me for helping me feel less guilty about wanting to cover the most exciting launch of Rocket Lab's career that I've been waiting for years. But also, I'm sure thank you from Rocket Lab, and of course, thank you from the Children's Hospital as well, from StarShip Children's Hospital. So if you guys can just thank everyone in chat on the way, because I might not be able to handle all of these tonight, like for sure. So that's amazing. This is extremely heartwarming. This is why I absolutely love, this is why I love the aerospace industry and the aerospace community, because you guys are wonderful people. Man, this is ridiculous. Wow, Jared Draper. I mean, I'm seeing you guys. I can't even. And Pork Hagen, Andrew Allen, Gavin. Jeez, guys. Wow. Okay. Let's keep going through this because we have something really exciting to talk about here. The mission name is Return to Sender. Notice that might be something important. So the launch provider for this is Rocket Lab. This is a Rocket Lab mission launching on top. Well, we'll get to that in a second. The customer is the TriSept, Unseenlabs, University of Auckland, Swarm Technologies, and Gabe Newell from Valve. I believe Gabe is who is actually donating to the Children's Hospital. Is that right? Is that correct? I believe that's right. I think if I remember reading, Gabe Newell donated charity for the Children's Hospital. So, if I recall correctly, you guys are unbelievable. Jeez. Okay. So the rocket tonight is, of course, Electron, which is the only rocket that Rocket Lab is currently launching. The launch location is Launch Complex 1A from Mahia Peninsula in New Zealand. The payload mass is a maximum of 300 kilograms. That's how much the new booster of this can fly, with kind of more the nominal payload mass of about 200 kilograms. These satellites are going to sun-synchronous orbit, SSO. Will they be attempting to recover the first stage? Yes. Yes, they will. Now, here's the deal. They are not going to be Joseph. Holy crap. Guys, what the heck? Wow. You guys, stop. I mean, don't stop. Don't stop, but wow. I don't know what to say right now. Oh my God. Okay, is Rocket Lab live yet? I don't want to miss that either. Okay, so the first stage will be splashing down softly in the ocean tonight. So they've worked on surviving the wall, they call it, which is just helping to guide the booster through the atmosphere. It just is going through the atmosphere. They've done that 2 or 3 times now. This time they're going to be pulling a parachute at the end of that. So it did require a booster upgrade. It also, they will not be attempting to catch it with a helicopter yet. That's going to be kind of phase 2 of this, or phase 3. So first, they're just trying to get it under parachutes, see if it splashes down softly, and holy crap! Guys, okay, so their stream's delayed a little bit. Hopefully this goes off tonight. Oh, wow. You guys are amazing. I can't even get through this. Look at this. Look at this. I don't even know what to say. Okay, so let me keep trying to do my job. I'm trying to remain a little bit composed here. So for today's mission, we might actually get some video. I don't know if it's going to be live video, but they did promise they'll send us what video they get. Might be some live video, of course. Transmitting through plasma, as we know, with watching SpaceX streams can be very hard. But there's a chance, if they survive, they should survive because they've made it all the way intact, mostly intact, they think, all the way till impact with the water without parachutes. We think they can get parachutes under this thing, and they're just using a more traditional drogue chute and a ring parachute for this particular mission. Now, they had originally talked about using an inflatable, some kind of hypersonic Balut, it's called, which would be pulled out first instead of a drogue. It looks like they don't even need that. It looks like the booster's terminal velocity is slow enough at the right parts of the atmosphere to be able to pull a more traditional drogue chute, followed by a more traditional parachute. We will see how we do. Oh, man. Every time I look over there. That's unbelievable. So we have a wayward plane in the range is what I'm hearing, why it's currently in a bit of a hold. Let's pull up. Let's see if we can. T0 time to allow an aircraft to clear the range. Stand by for your target liftoff time. Okay, so get out of there, airplane. We're waiting to see a rocket fly. Okay, so let's get back to this. So will they be, where will they land? The first stage will splash on approximately 650 kilometers downrange. Will they be attempting to recover the fairings? No, this is not a capability of Rocket Lab. This will be the 16th launch of Electron ever. The first attempt at first stage recovery, but again, not quite the full version of the first stage recovery, but more an attempt to at least just get it back. And then the plan is to kind of swoop it up from the ocean and see how it did. You know, like they even have plans to go and they've even practiced this where they're going out to the booster as it's floating, because remember, it is a sealed pressure vessel, of course, so it will float. And as a matter of fact, it might float vertically because of the heavy weight of the engines. I'm not entirely sure about that. But yeah, it will be floating. They'll attach some extra things once the vehicle's safe, load it up onto a boat, and then they'll be able to inspect how did it come back in through reentry. Are we ready to move on to the next step? So this will be the sixth. Are they attempting to recover fairings? No, that's not a capability of Rocket Lab so far. SpaceX is the only one to attempt that. This will be the 16th launch of Electron ever, the first attempt at a stage recovery. So here you go. This is our little graphic here if you guys need to watch. Remember, Electron is tiny. Electron's only about 17 meters tall, so about 60 foot tall. It's 1.2 meters wide, so under 4 foot wide. This thing is very small, but it's an impressive. This is also the first. We probably should, Trevor or who wrote this? Hold on. I'm going to talk directly to you. Austin, can you go ahead and add in this article at some point that this is the first block upgrade version too? Of the booster. So this one, they did add, so here's kind of the mission profile of what we're hoping to see. We should see water landing. We should know about T plus 13 minutes, how the booster did. So we'll see. And here's some pictures of the satellites. Again, some of these are tiny little CubeSats, which are super cool. This is Noam Chomsky here. So this is what I'll read about this, because this is the part going to the Starship Children's Fund. So it's Noam time. So Noam Chomsky will act not only as a math simulator, but also to test new 3D printing technologies for satellite parts. This particular Noam was manufactured in support from Weta Workshop, an award-winning design shop in New Zealand that was founded in 1987. At 150 millimeters tall, the Noam refers to a Half-Life gaming icon, Noam Chomsky, but it will also test a titanium 3D printing technique that could be used on future satellites and satellite parts. Gabe Newell from Valve will donate $1 to the Pediatric Intensive Care Unit New Zealand Starships Foundation for every viewer on Rocket Lab's live stream, which again is why it's important that as soon as they go live, we have all of you guys watching that as well, the official live stream. So this was the original Balut idea that has been scrapped for a more traditional parachute. If you guys need to know more about how they're going to recover, again, some of this has changed. They might not ever go to a steerable parachute or a parafoil like this because if it has enough hang time, the biggest thing isn't necessarily trying to guide it to a certain exact location under a parachute. It's more just to guide it into the wind to increase the hang time of the booster. But there's a chance, as long, if there's enough hang time for the booster to be able to just be sitting there under a normal parachute, that they won't need a parafoil of any kind. A circular ring could be fine. Give it enough time for a helicopter to swoop by and grab it. No big deal. So yeah, if you guys need any more information about this rocket, about this mission, definitely read through our pre-launch preview. And everyone say thank you to Austin DeSisto. Thank you so much, Austin, for all your help, and to the rest of the website crew. And of course, thank you to all the moderators in chat that keep everyone on track. Guys, I can't even... Normally, I say thank you and answer questions and do all of the things, but I don't know what to do. I just honestly don't know what to do here. Yeah, other than tell you guys that Team Space is amazing. Aaron, thank you so much. That's very generous. I mean, wow. I'll just read a couple fun ones. Jonathan Lowry, 5 years ago, you inspired me to pursue space. Now a senior in high school, I'm pursuing aerospace. My future Martian Society shirt and you have all and will continue to keep me going. Thank you. That's awesome. Thank you. Zachary, kudos to the live stream. Also, by the way, our chat system is not seeming to work tonight, the thing that we normally use to put chats up on screen. So unfortunately, it is getting, yeah. So Ranger One in our Discord wants to know, just out of curiosity, do viewers in my live stream count towards the charity? I don't think so, which is why we're trying to make sure to be extremely transparent and push everyone to the official live stream once it goes on air. That's extremely important. I don't have any arrangement. I've never talked to Gabe Newell from Valve. I have no idea about whether or not they would consider views on this stream towards their charitable contributions. No idea. But guys, at this point, holy cow, there's a chance that we'll almost match the stream contributions just in the viewership and just chat and super chats. That's absolutely insane. I mean, thank you guys. Yeah, so again, just to reiterate what is going on for those of you that are joining, because there's more here than now. So tonight's, I've been very hesitant to stream, but this is like the mission that I've been waiting for so long. And I was really conflicted about whether or not to stream this tonight, because for every person watching the official Rocket Lab stream, not this stream that you're seeing right now, the official Rocket Lab stream, Gabe Newell from Valve will be donating $1 to the Starship Children's Hospital in Auckland, New Zealand. So as to not take away from that, we are going to be reiterating that annoyingly tonight so that we make sure that if you are only watching this one, if you are watching the official stream. So if our numbers for any reason are higher than theirs, like, I'll shut it down, because I think that's more important, because they will be donating $1 per view. So that's massive. If we have hundreds of people over here that are not watching the official one, that's hundreds of dollars that would be taken away. So what I decided to do, I talked with Rocket Lab about it. I think that the best thing we can do is we are donating all super chats tonight to the charity. So what I'll do is I'll whatever's up on screen, because YouTube always takes like a good chunk of the money for a super chat. So I will make sure I'm actually matching what comes in. So I'll make up the difference. Hopefully it's not like 30, it might be like 30%. We'll figure it out. Can someone let me know, actually, so I don't accidentally get stuck with like a $8,000 thing or something? Can someone let me know what the super chat rate is? I know it's not great. I don't think it's like 4% or something. I think it's like maybe 10 or 20. It is 30. Crap. I don't know if I should probably do that though, but I don't. Yeah, actually, now the more you guys donate, the more I would have to pay. Maybe we'll split the difference. Because I don't know. Oh, man. 7 for the kids, 3 for YouTube. How about this? I'll match it. Wait, right now it'd already be, oh, geez. I don't know what the best way to do this is. Wow. That's not a bad idea. We could maybe see if we can get Gabe to match the YouTube difference. Let's see. Okay, yeah, we are getting... by the way, James with a $500 donation. Joseph used this on the 30. See, I just don't know what the best thing to do is now, because 30%... I'm literally already at thousands of dollars. So maybe, how about this? Because you guys are being so generous, I'm going to personally donate 1,000. Okay. So we'll take this. I want to be transparent about this because I don't want you guys thinking that your money's for what is clearly a charitable thing in any way going into my pockets. So I will donate $1,000. I will show the paperwork. We'll put up this $1,000 on top of like what comes in here. So that way, you know, I'm not, because 30% of that number is getting spooky. I think that's what we should do. I'll donate $1,000 from my personal account. So then all super chats though, the revenue from the super chats, because YouTube takes 30%, will get donated to the Starship Children's Fund. I think that's the right thing to do, right? I think that's the right thing to do, right? I really wish that YouTube would allow us to like have all the super chat. We actually tried to do a charity, but a charity has to be to make it a charitable fundraiser. The charity has to be pre-approved by YouTube. So we couldn't directly wire it to the Starship Children's Foundation. So, yeah. Oh, Rocket Lab. Oh, you guys. That's adorable. Hang on. Oh, look, Rocket Lab responded. Well, Rocket Lab, don't worry. We've got lots of people here to support with you guys. So I think it's beautiful what you guys are doing, and you know, I think that's about the only thing that'd be the right way to do things on my end. You know, because the last thing I want to be is a YouTuber that's like, you know, there's a charitable live stream happening tonight, but yeah, you know, I gotta get those views. I gotta get them views up. So yeah, maybe. Okay, so since we have so many people, one of the things we could do, why don't we do this? At Discord channel, can someone look and see if there is a direct way to directly contribute to Starship's Children's Fund and be able to like notate it Rocket Lab or something so we can show that we're helping to do it more directly? Because that might be a better use of our money here. Instead of giving YouTube at this point thousands of dollars, no offense, YouTube, I love you and I'm glad that you have a platform, but thousands of dollars for what's trying to be a charity is yeah. Here we go. Starship.org foundation/donate. Let's do this. I'm going to put this in the description. So check the description below. Maybe this is going to be a stronger use of the donations. I'm typing and talking. Instead of super chatting, maybe contribute directly so YouTube doesn't take 30%. Okay, there we go. There we go. It's in the description now. So if again, to reiterate, if you are considering donating to avoid the 30% going to YouTube, maybe the best thing we can do is donate directly to the charity, which is now linked in the description. Yes. So there we go. So starship.org.nz /foundation/donate. So, yeah. I think that's the best thing we can do. You guys are unbelievable. Yeah, thank you. So let's see if we can answer some questions. What questions do you guys have about tonight's rocket launch? It is, after all, going to be an incredible, it will be an absolutely incredible mission. So tonight it will be awesome. Pin that donation link to the launch video too. I don't know, but we really want that up top first and foremost. So, Flo, to catch you up, Flo in our Discord doesn't know. So yeah, we decided we're going to be donating any super chat money, the proceeds of the super chat money to the Starship Children's Fund, because remember tonight, in case you're just now tuning in, as soon as Rocket Lab goes live with tonight's launch, we will be all tuning in there, and I will be encouraging everyone that's watching my stream you can only watch my stream if you're also watching the Rocket Lab live stream. You cannot have just my stream open. You'll get a naughty, you'll get lump lump of coal in your stockings. That's what will happen. You'll be on the naughty list. You don't want to be on the Tim Dodd naughty list. That's no good. So, yeah, we will be keeping an eye on that. And if at some point Rocket Lab's live stream is smaller, check this out. So right now they're at 20,000 people waiting. That's what we want. At this point, so as long as that's higher, for each person that's going to be watching this live stream, the official Rocket Lab live stream, it will be $1 donated to a charity, so to Starship Children's Fund. So, okay, so Brant wants to know, what are the chances of Electron rapidly rutting or rapidly rapid unscheduled disassembly? So the chances, I mean, on ascent, very low. This is already an extremely reliable, highly flown rocket. You know, it has had one flight hardware issue in flight, and it was, of course, unlucky number 13. But it was one of those things that they had never experienced. It's one of those unknown unknowns where you don't know something's going to fail until it does. It was a connection issue between the batteries, basically somewhere between the batteries and the motor, because don't forget the Electron runs on electric motors, on electric pumps. So instead of using a turbine and having a small rocket engine power a turbine which spins the main rocket pumps, they literally just have electric pumps. And I know that sounds efficient, and it actually is. I mean, by definition, it's almost 100% efficient, except for the weight of the batteries are extremely. Lithium ion's density is like 1/100th the density, energy dense as rocket fuel. So actually using rocket fuel as your energy source is actually a lot more efficient overall for a launch vehicle. But Rocket Lab has made it happen. They have proven its reliability. They've proven it to be a simple, easy development path forward to make a reliable small sat launcher. And so, So, as far as it rutting, I expect no problems. I expect no problems with the launch. I expect it to be a fully successful mission. The only thing that's really changed, we do have some pictures of what this new booster will look like, because it has actually changed. So let me show you guys what it actually looks like here. So the booster itself, they painted the inner stage white and the rocket itself is black. So this is basically a reverse Falcon 9 now, where check this out. So, the Falcon 9 is white and has a black inner stage. This is the opposite. This is all black with a white inner stage. That's how we know this is the new block upgrade of this particular booster. So what we can kind of see here, there's a few things to point out. So obviously they are packing parachutes inside of the interstage. So the interstage is the place in between the first stage and the second stage. The second stage engine, which is very large because it's optimized for the vacuum of space, is inside that interstage. So the interstage houses, you can see it right here kind of on the planet part, has little tiny cold gas thrusters. Again, very much like how the Falcon 9 does it. It's a simple solution, but the thing is, the Electron is so apparently mass efficient, or whatever characteristics it has, it does not relight its engines after boosters shut off. So once the stages are depleted, and as a matter of fact, they can actually run the stages to depletion without worrying about destroying the engines. A normal turbopump engine, if you let it suck in an air bubble and then, kind of sip on some gas, it can lead to really nasty transients and nasty shutdowns and nasty, really bad combustion instability, which can destroy the engine. Now, the Electron, because it runs on electric pumps, as soon as they stop sucking in fuel, they don't care. They can spin down the pumps, no problem. There's no risk of really unstable combustion. So they can actually run these tanks completely dry. And then the booster will basically orient itself and make sure it's pointing perfectly retrograde, or the engines are facing exactly retrograde. And then they will fly basically with the engines forward, and it survives that reentry by just staying pointed. The problem is that if the booster were to lean and come out, and start to fall in any other way, if the plasma from the reentry were to attach to one of the walls of the booster, it can destroy the booster. So they just have to make sure the engines are 100% facing forward, and that nothing inside the wake of the booster is attaching to the booster, so that the plasma developed during reentry, they just have to make sure that the booster itself does not come in contact with that at all. And they can get it all the way through the nasty, brutal reentry and they can get to the point where so far they've hit the water with no problems. So that's awesome. So the next part of that is once they're at terminal velocity or at a slow enough altitude or low enough altitude and a slow enough velocity, they are now going to be pulling a traditional drag chute. So, yeah. So it's going to be a really exciting mission to see because, yeah, not only is, normally the booster, once it's done, just tumbles off and falls back, gets destroyed mostly on reentry, and then finalizes its demise once it splashes down. But as we see more and more, the first other vehicle to really look into that and really do that successfully was the space shuttle. Of course, the space shuttle had solid rocket boosters, and those were powered by, or those came in through parachutes, and they had no problem. Now the space shuttles, actually, I have if only someone had a chart about all this stuff. Everyday astronaut, rocket lab, parachute. Let's see if I can find it. Okay, so we have some interesting charts here because I actually compared the velocities and the altitudes. And I actually think we need to change this out a little bit because I think the Electron doesn't quite go this high. I think I heard some numbers on a recent thing that we might need to change this. This was based on a year ago on some missions. They may have changed that trajectory out a little bit. But so look at the little green line here. You can tell that that green line is the space shuttle's SRBs. So they didn't go very high, and they definitely didn't go very far, and they didn't have too much velocity. As a matter of fact, the shuttle SRBs only got up to about 5,000 kilometers. Now compare that to the Falcon 9 booster, which will go up. The first stage of the Falcon 9 gets around 8,000 kilometers an hour. The Electron booster from our previous data got up to about 7,500 kilometers an hour. So the Falcon 9, experiences substantially more heat and the Electron booster than the SRBs. The SRBs just did not perform that much work. So, are we, so if we look at this, that's one of the reasons why the SRBs could survive reentry without any additional guidance. They could just tumble into reentry. They literally tumbled as they reentered and didn't matter. They're these relatively thick casing and they could just handle high temperatures, and they just let those things tumble through reentry and then pulled chutes, and then they let them splash down. Now those boosters were way too big to try and do air recovery. The Electron is tiny. Don't forget, the Space Shuttle SRBs were almost the exact same size as a Falcon 9's first stage. And basically the boosters of a Falcon Heavy, that's about exactly how big a Space Shuttle solid rocket booster is or was. So trying to catch one of those with a helicopter would just be unfeasible. Now, the Electron is tiny. The Electron is a lot smaller than that. Again, 17 meters tall versus 45 meters tall. So 3 times taller for the shuttle SRB. So yeah, these are kind of showing where so this, if you guys want to learn more about this, I already kind of did a video about why I think the Electron can do it, what's different about it compared to, say, the Space Shuttle's SRBs versus, say, the Falcon 9. And just for fun, look at how far out the Vulcan first stage, that thing gets pretty darn going. That gets 2/3 the velocity of orbital velocity. It is really cooking. So yeah, that's really interesting. It has to do a lot of that work. Rocket Lab is starting. All right, everybody, it is, relatively soon they're starting. So I'll be keeping an eye on this for you guys. Hopefully this airs pretty soon. I'll let you guys know as soon as it does, and we'll go live. And I will be reminding you that you cannot watch my stream tonight unless you're also watching Rocket Lab stream. That is a rule. So, yeah, that's true. Aviation points out that the Vulcan booster will go quite far downrange and go quite fast, but nothing like the core stage of SLS. Core stage of SLS will be screaming. Okay, everybody, here we go. We do have the Rocket Lab stream up. So everybody, right now, ladies and gentlemen, if you are hearing my voice and you do not have this official Rocket Lab live stream, you cannot partake. You are naughty. We have to have that up because, again, for everyone watching the official live stream, that will be a $1 donation for the Starship Children's Fund, which is, let me pull that up again just because I think I had some people wanting to know more about that. Here, we can just go here. It's Auckland Starship Children's. I can't spell. There we go. Good enough. So the Children's Hospital in Auckland, New Zealand, Yeah, this is the page for it. If you guys are curious, again, we actually have the link directly. Instead of doing super chats, we are suggesting that people go directly to starship.org.nz, and then there's /foundation/donate. We're just trying to match and add to the charitable foundation and the charities that are going to be received during tonight's launch. So I'm not hearing anything from their launch yet. So, okay, let me know if you guys, please let me know if at any point our stream goes above Rocket Labs. I'm going to shut her down. Okay, cool. Hopefully that works out okay. Good. They do have more then. So what else do you guys have in mind? Let me know what other questions you guys have tonight, because again, this is a mission that I'm extremely excited for. I can't wait to see, what actually is going to happen. If we get streaming video during reentry and or streaming video, after the chutes have been pulled from the booster, I'm going to be very, very, very excited. All right. So yeah, we're getting close. We're only about 27 minutes away. This is going to be a great launch. Again, it's fun to see that they were actually able to increase the payload capacity and still put parachutes. Because don't forget, parachutes, it's not just the weight of the parachutes. It's also the fact that you have to have, the parachutes, when they pull on something, those attachment points need to be beefy. So you'll actually notice the inner stage slightly gets a tiny bit wider. Maybe, it might only be like 10 millimeters or something, but it gets a little tiny bit wider. And some of that is probably having to do with beefing up the attachment points of the parachutes of the booster. Because don't forget, once those parachutes, deploy, there's some pretty strong loads there, especially on all of the cords and everything that pulls, and it has to be attached to something really strong. So you're adding a lot of weight, not only to, house the parachutes, but also to have the attachments to those parachutes. But don't forget the first stage. Again, I've a really, I love talking with Peter Beck, the CEO of Rocket Lab. I had an interview with him last year on their launch pad, their new launch pad in the United States at Wallops. And I asked him, so what's the payload penalty for attaching, say, a kilogram of weight to the first stage? How much does that detract from the upper stage? Now, with SpaceX's Falcon 9 rocket, it's something around 4-to-1, 5-to-1. For every 4 or 5 kilograms you attach to the first stage, it detracts 1 kilogram from your payload capacity. That's because, obviously, if you have more weight, you're taking away the ability to put more weight up on top of the rocket. And the reason that the first stage isn't as affected is because the first stage is suborbital. It's only doing a quarter or a fifth the amount of the velocity of the vehicle. The upper stage is the one doing the bulk of the actual work, believe it or not, even though it's a smaller portion. So the Rocket Lab, the Electron, it's only about an 8-to-1. So for every 8 kilograms of weight, they actually can, it only takes away about 1 kilogram. So you could actually defer that, pretend all the numbers were the same and they didn't do any other upgrades to the booster. You could actually probably figure that, the parachute system could be 800 kilograms, and you'd only see a 100 kilogram decrease in payload capacity, which would still give it 125 kilograms to low Earth orbit. Now, the thing is, they actually upgraded it, and it's now capable of 300 kilograms. It used to be 225 or 250, I think 225 kilograms to low Earth orbit. Now the Electron's capable of 300 kilograms. So they actually increase payload up to 300 kilograms. That might be with the kick stage. So sorry, we're double checking. So the gnome thing, let's go back over the gnome thing, because that is kind of fun. I see questions about that in the in our Discord channel. So the gnome here, my friend, is right here. So this is a Half-Life gaming icon, 150 millimeters tall, 150 meters tall. This thing is really big. I don't know how they fit it inside. No, it's 150 millimeters tall. It's made out of 3D printed titanium. So they're hoping to see how it handles a vacuum environment. So they made it out of this. It's also just kind of a payload mass simulator. And Gabe Newell will be donating. This is the part that's so important, that Gabe Newell will donate $1 to the Pediatric Intensive Care Unit, New Zealand Starship Foundation, for every viewer on Rocket Lab's live stream. So Yeah, there we go. So that's what the gnome is all about. So how are we doing here? Are they still? We better still be smaller than them. Let's double check. Hold on here. Where did that go? Just making sure. Hey, where did it go? They're at 24,000. I'm actually gonna pull this up on a separate browser so I can keep tabs on it at all times. Make sure we're not detracting from the potential. Give me 1 second here. I'll go back and go full screen here for you guys. Okay, so I've got them pulled up over here too. And there we go. So yeah, 24,000. Okay, so we're still doing good. We're still doing good. You guys have just absolutely blown me away tonight. I'm like in shock. Warren Parks on YouTube says, how many kids could this launch? Hashtag for the kids. I mean, let's see. At 300 kilos, what's a kid weigh? A kid weighs a good 50 pounds. So 22.5 kilograms or whatever, something like that. So, this could you could roughly put seven children inside of this. I don't think they want it. Peter Beck has vowed to never fly meat. He says he doesn't want to fly humans. So, you know what? Oh, embedded videos do count towards the live stream. That's cool. That's awesome. So, you could probably do like 7 children without any life support or any other vessel. This is getting weird. Probably just better that we stick to the live stream, to the topic at hand. So yes, we do have a little bit of Rocket Lab audio coming through. Hopefully they go live soon here so we can listen in and see what we're going to learn tonight. That is awesome. Peter wants to hire me for ideas. There's in Discord, a hot air balloon version. That's actually, imagine a hot air balloon powered by rocket engines. Why don't they just, have a hot air balloon, have the booster fall backwards and just kind of light your engines a little bit to heat up the balloon. There you go. Wow. That is awesome. Maybe add the official Rocket Lab Twitch link to the description. I could do that. I don't know if that will necessarily aid. Will that? Yeah. I'm over here doing why don't they just. Okay, so here's the official Twitch. I'm going to add that too. If anyone wants to watch on Twitch. Okay, that's added to the stream too. So, honey, you must be new here. We've been talking about this all night. We're not donating a portion. We're donating all super chats tonight. That's in the description. It's also a pinned comment tonight. All super chats are going to the Children's Hospital. YouTube takes 30% of that. To make up for that, I am personally donating $1,000 tonight as well. I will be posting the transparency of that tonight. So, yeah. We are fundraising a lot of money. A lot of money. So yeah, click oh, that's not a bad idea. Someone says, click the 3 dots at the top right of chat and send feedback. The only thing is, the only deal with YouTube, we wanted to make it just a direct fundraiser, but you had to have, actually, wait, hang on. Andrew, can you double check? So I know that there is, Tomorrow Chat is working now. Awesome. Let me refresh it. There we go. So, man, you guys are amazing. Again, thank you. Thank you on behalf of the Starship Children's Fund. But yeah, the only thing is we tried to make it so it would just directly do charity, but you have to have like a pre-approved charity. So again, we do have the link to the charity because I'm just trying to do what Rocket Lab's doing, which is donating portions to starship.org.nz/foundation/donation or donate. So check the link in the description. Chad says not everyone can be an astronaut, but everyone can be a satellite. Do you guys know about the time that there is SuitSat? This is one of the creepiest things I've ever seen. So this is one of those fun spaceflight moments. At one point, how did this work? I don't remember the whole story. I'm going to read about it now while we're waiting. But SuperChat is absolutely amazing. SuperChat. Okay, so this was, let me real quick. This is, they put a radio basically inside of an EVA suit, a Russian EVA suit, when they needed to discard it. And they just literally pushed this EVA suit, which, by the way, when semi-pressurized, looks an awful lot just like a person floating off into space. They just literally pushed it out. Was it at the space station or was it, yeah, the space station, International Space Station. and this suit, the spacesuit just went tumbling out into space. There's no one inside it, of course, but it's still just super, super creepy, to be honest. SuperChat, scary. Yeah, SuperChat was the original imposter. You're exactly right. Okay, let's listen in here. I can't wait. Make sure remember right now, important. If you're watching me, you have to be watching the official live stream. Click right now.
Thank you for joining us for our 16th Electron mission and our very first attempt to recover a first stage as part of Rocket Lab's efforts to make Electron a reusable launch vehicle. You're looking at a live view of Rocket Lab Launch Complex 1 in Mahia on New Zealand's east coast as we count down to a 3:20 PM New Zealand time liftoff. Today's launch is our 6th mission for the year, a mission we've aptly dubbed Return to Sender. I'm Ariana Ryan, and I'm a quality engineer in the propulsion team.
And I'm Max Muncy. I'm a data analyst here at Rocket Lab, and it's great to be back with you for our 16th launch. We're in the final stages now of launch preparations as we count down with 17 minutes remaining on the clock to lift off for this mission. Electron's primary mission today is to deploy a diverse range of payloads to orbit. Inside Electron's fairing, we've packed in 30 small satellites from customers in the United States, France, and New Zealand. Before we get into those customers and satellites, though, let's talk about reusability. Today's mission marks a major step in our goal of turning Electron into a reusable rocket, and is our very first attempt at recovering an Electron booster after launch. Electron's first stage has been expendable on all 15 missions to date, but for the first time, we'll be trying to bring the stage back underneath a parachute. We're aiming for a soft splashdown in the ocean, several hundred kilometers downrange from LC-1, where our recovery team will extract it from the water and bring it back to our production complex for inspection. While the ultimate goal is to bring back a fully intact stage, today's recovery attempt is very much a test.
Yeah, so regardless the state the stage comes back in, our team will come away with lots of data and information for our future recovery efforts. And, as a reminder, today's recovery effort does not include an attempt to catch the booster mid-air with a helicopter. That will come in future attempts once we've completed successful parachute re-entries. So, right now our recovery team is ready and in position in a vessel in the Pacific Ocean, close to where we're expecting Electron's first stage to splash down at about 8.5 minutes or so after liftoff. We'll try to bring you live footage from the camera on board as the booster begins to make its descent, and we'll stick with the feed as long as we can, but we are expecting a telemetry dropout as the stage reaches 30 kilometers altitude on its descent. To tell us more about how we're approaching rocket reusability with Electron, let's hear from our CEO Peter Beck and the recovery team here at Rocket Lab.
It's been enormously fun along the way. This has been the best project almost, doing these big scale tests where there's lots of energy, and it's been super fun. We set out at Rocket Lab to try and recover the vehicle, primarily to increase production. And first I didn't think it was feasible to do with a small launch vehicle, because if you look at all the traditional approaches, they're just not going to work. You don't have the propellant margins in a small launch vehicle. So we had to look at different approaches, and as we started to pull real data from real flights, it became obvious that there was an approach that could work. It was a little bit unconventional, and we started off down that path.
So after separation, it will coast on up to apogee, do a flip, come in engines first, accelerates for a while as it comes in, and then decelerates, getting very hot in the process. Once we're down to about Mach 1.5, we'll activate a mortar, which will deploy a drogue parachute. That will slow it down further, and then when we're down to 2 or 3 kilometers altitude, we'll extract the main parachute, which is a big 18-meter ring sail, and that will slow us down to a fairly modest velocity of about 10 meters per second, where we'll take a splash in the ocean. A lot of it comes down to just the size and mass constraints that we're dealing with. Trying to package a whole load of extra equipment, mortar, extra parachutes, reaction control system, gas bottles for that, and the additional electronics into a volume that's already very tightly filled with the second stage rocket engine and battery compartment. that was probably our biggest challenge.
The most important thing that we're trying to achieve here is just to get the stage down to Earth in one piece, or as close to one piece as possible. So we won't be trying to scoop it out of the sky with a helicopter. We have demonstrated that we can do that, so I'm not too worried about that. The real challenge for us here is getting it through the wall, getting it under a parachute, getting it decelerated, and gently touching down into the ocean, where we'll go and pick it up with recovery vessels.
Okay, the main parachute on the stage is a ring sail parachute. This was a design that NASA used way back at the sort of dawn of the space age. The same design used for the Mercury and Gemini and Apollo spacecraft.
It's much easier to deploy, especially at high speeds, which means we don't need a complicated parachute system to get it out there. So that's why we've chosen ring sail parachute for now, as opposed to a kind of gliding parachute that we looked at previously.
It's kind of like a CSI scene. We really start to peel back the onion and understand exactly what's happened. There's nothing like actually having a flight article that's returned to understand the margin here and the margin there, and which bits really worked well and which bits are just roasted up completely. If we get the stage back, we'll have a really good idea of how much work we've got ahead of us. Recovery for our customers is really about making sure that there's more launch opportunities available. If we can recover a stage, we can open up many more launch opportunities and create a much more flexible environment for our customers to pick and choose which flight they want to get on, ultimately try and lower the cost, and just make launch even that more prolific.
That's awesome. I'm so stoked.
So as you heard Peter Beck mention there, our ultimate goal for this attempt is to fish an intact booster out of the ocean that we can transport back to our facilities to check out what we've got. Keep an eye out on our social media channels for updates on what we find at the end of this live broadcast and in the weeks to come.
So we're coming up on T-minus 12 minutes, so let's check in with the launch director, Sean DeMello, and the rest of the team for the final go, no-go poll.
For launch. Stage.
Stages go.
Avionics.
Avionics is go.
AFTS.
AFTS is go.
GNC.
GNC is go.
VCON.
VCON is go.
T1.
T1 is go.
GC.
GC is go.
BLS.
BLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
Recovery.
Recovery is go.
LDSUP.
LDSUP go.
Executive.
Exec is go for launch and recovery.
Go no go sequence complete. We are at T-minus 11 minutes, 37 seconds and counting. We are go for terminal count starting at T-minus 10 minutes. From this point on, 3-word hold procedure is in effect.
Oh, guys, I'm seeing some beautiful comments. Kelly, that's amazing. Wow, our 4-year-old had a surgery at 10 days old. Now he loves watching rockets with me. Thanks for this. That is so cool.
And there you have it. Our operators and launch director have confirmed Electron is primed and ready on the pad at Launch Complex 1. Now to the customers on board this special mission. The satellites for this launch span a range of operations, from tech demonstration through to maritime surveillance, communications, and education, as well as a final special guest hitching a ride to space. Today's mission will launch the APSS-1 satellite from the Auckland Program for Space Systems from the University of Auckland here in New Zealand. This is a particularly special payload because it's New Zealand's first student-built satellite. APSS-1 is designed to measure electrical activity in the upper reaches of the Earth's atmosphere, right at the edge of space, a region known as the ionosphere. Because the ionosphere is ionized by solar and cosmic radiation and is affected by phenomena such as solar winds, it is uniquely reactive to the changing magnetic and electrical conditions. That means it affects radio and GPS signals here on Earth, including television, internet, and telephone communications. But scientists are also curious to what extent and how the ionosphere is affected by geophysical activity here on Earth, including whether the electrical disturbances that occur in the ionosphere might be correlated with earthquakes. More than 26 students have worked on this satellite across several years, so we're very proud to be delivering it to space today. To support innovative student projects like this one, Rocket Lab is providing the launch service to the Auckland Program for Space Systems at no cost.
Next on the list is the drag racer payload from US company TriSept, which is designed to test new tether technologies that could accelerate spacecraft re-entry and reduce orbital debris at the conclusion of space missions. TriSept's payload includes two 6U smallsats, one with a tethered drag device measuring 70 metres long and the other without. Next up, we're welcoming a return customer back on board Electron, following the first successful deployment with Rocket Lab in August of 2019, French company Unseenlabs. This launch includes two of their satellites to grow their maritime surveillance constellation. Both of these small sats independently and precisely locate and fingerprint radio frequency emitters all around the globe, day or night in any weather conditions, and without requiring any special embarked tracking device.
That's right, and 24 of the satellites on board today's mission include the latest quarter-U Space Bee satellites from Swarm. These Space Bees are designed to provide affordable satellite communication services to IoT devices in remote regions around the world. And finally, fans of the game Half-Life will recognize our very special guest on this mission from Valve co-founder Gabe Newell. I'd like to introduce you to Noam Chomsky. That's right, we are launching a garden gnome to space, or to be more precise, a mass simulator in the shape of a garden gnome. This little guy right here is a replica of the one sitting inside Electron's fairing, which is about to head to space. Manufactured with support from the Weta workshop, this tiny astronaut will finally complete his achievement for real. Because we have a no gnome left behind policy here at Rocket Lab, Mr. Chomsky will remain attached to the kick stage and deorbit with it as it falls back to Earth.
Not only does this mission serve as a tribute to the innovation and creativity of gamers worldwide, but Gabe Newell is personally donating $1 to the Pediatric Intensive Care Unit at Starship's Children's Hospital for every person who watches the launch with us today. So thank you so much for tuning in. And thank you to all of our customers for choosing to ride on Electron. We couldn't ask for better mission partners, and we're proud to be working with you all.
Yep, that's why everyone, I'm making sure that if you're watching this, you have to be watching the official live stream. You cannot be watching just me. You have to have the official live stream pulled up somewhere else in your house, either another computer or a TV or a tablet or phone or whatever. Don't watch just me, because there's a charitable donation here, and we are, of course, matching Super Chats tonight. All Super Chat donations, the proceeds from the Super Chat donations will be going there. And I will be, to make up for the 30% that YouTube takes, I am personally donating $1,000 as well. And I will have the receipts to back that up in the future. So, all right. So this, again, guys, really exciting mission. We've seen some really, really, really great, really great questions and stuff from you guys. One of them was kind of funny. Sam says, "Hey, Tim, have you contacted SpaceX to get my music on their live stream? So it would have been amazing to hear your music on the coasting phase last week." Not with SpaceX directly, but I am currently collaborating with the music.
Avionics LD on mission.
Hang on.
LD avionics.
Proceed with sequence 51, AFTS enabled for flight.
Proceeding with sequence 51.
The flight termination system is enabled. So I actually am collaborating with Test Shot Starfish, who does the music for SpaceX. I don't exactly know where that song will be used.
AFTS is green.
Who knows, that might end up in a SpaceX mission at some day, but yeah, that will be coming out, I think, before the end of the year. So, yeah. You guys are so awesome.
The 18-metre tall Electron is made of 2 stages to get orbit and a 3rd stage for precise deployment of the satellites on board. Electron's 9 Rutherford engines at the bottom of the 1st stage do the heavy lifting to space before the 2nd stage separates to carry on the mission. The 2nd stage is powered by a single electrically pumped Rutherford to get to orbit, before Electron's kick stage takes over and carries out the final leg of the journey to deliver the satellites on board to their specific destinations. Once stage separation occurs, approximately 2.5 minutes into the mission, Electron's 1st stage booster, which you can see on your screen there, will begin its descent back to Earth, and it's this part of the rocket we'll be attempting to recover on the mission today.
To support this mission's recovery attempt, we've added some extra hardware and components to Electron's 1st stage. Here to tell us more about what's been added to Electron is Dominic Fu, a familiar face and integration technician whose team assembled the rocket and the recovery hardware. He joins us now from Rocket Lab's main production facility. Dom, what can you tell us about the differences on the 1st stage for today's mission?
Hey Max, that's right. The 1st stage on Electron is a little different on this mission, but it's not just a paint job that's new. I'm standing on the factory floor here at one of our production complexes, and behind me there are about 7 Electron rockets, all lined up for missions later this year and early next year. Right here is where the 1st stage for today's mission was fitted with recovery systems that will hopefully enable us to bring the stage back under a parachute today. Now, approximately 2.5 minutes after liftoff, at an altitude of around 80 kilometers, Electron's first and second stages will separate. Electron's second stage will continue to orbit, where the kick stage will separate and deploy the satellites. So up until now, we're following a standard mission profile. But next is where it gets interesting for recovery. With engines now shut down on Electron's first stage, our reaction control system will reorient the stage 180 degrees to place it on an ideal angle for re-entry, designed to enable it to survive the incredible heat and pressure known as the wall during its descent back to Earth. Now on the recovery booster, the RCS thrusters are located near the top of the vehicle, highlighted on your screen. When Electron decelerates below Mach 2, a drogue parachute will be deployed to increase drag to stabilize the first stage as it descends. In the final kilometers of descent, a large main parachute will be deployed to further slow the stage and enable the controlled splashdown. Our team on the recovery vessel will rendezvous with the stage after splashdown and retrieve it for transport back to this production complex for inspection. Once we get the stage back to the factory, we'll inspect every inch and use that knowledge to inform our next recovery effort. It's going to be such an amazing mission to watch that I'm just going to wrap this up right now. I'm going to join everybody else at Mission Control. Back to you, Max and Ari.
Thanks very much, Dom. The recovery team might be leading the program to bring back an Electron, but almost every team across the business has been involved in getting us to this point. So it's exciting to be just minutes away from liftoff for this very special mission. A quick reminder that we will have live video of the beginning of the recovery process. We're expecting the feed will cut out as Electron goes through the wall and eventually drops out of telemetry range. We'll be sharing photos of the recovery effort on the water as soon as they're available. So, with just 2.5 minutes left in the count, we're going to hand you over now to listen in on comms from Mission Control for the final minutes until launch.
And I know that Rocket Lab's waiting for this. I know they
All
didn't
stations LD on mission
include it
core.
in their
We
pre-launch,
are go for
the go no go poll. But I do want to actually confirm. Again, this is very difficult when you're talking about Rocket Lab, being from New Zealand, pointy end up, flaming end down. It gets a little more complicated, but I have, of course, been certified for these launches as well, and I can confirm. I'll have to wait for the next shot because this one's a little far away. But I can tell actually. I've got enough resolution here. The pointy end is up. The flamey end is down. Rocket Lab, you are go for launch here from from Everyday Astronaut #Team Space. Oh, I'm excited, guys.
AV bits are on internal power.
Is that not the most gorgeous launch pad in the
Vehicle
world?
is fully on internal power.
Guiana Space Center is pretty too, and so is where ISRO launches and rolls out their vehicles is stunning as well.
Flux load is complete. System is in recirculation.
Jamie Higginbotham wants to know, so if they recover this, Peter Beck agreed to eat his hat because he'd be eating his hat for, saying that they would never try and recover a booster. That recoverability just wasn't an option for small sat launchers. So he might have to eat his hat, and if so, is he allowed to get condiments with it? So I'm guessing actually if he literally eats a hat, I mean, he's actually said like, I will genuinely eat a hat. I could see him blending it up a lot and putting it in like a smoothie or something and just having like a small bite of one or something. But yeah, I think he did say he was making a smoothie, if I remember right. I think I saw that somewhere. So that might be another live stream.
Stage 1 and Stage 2 tanks are pressed.
Yes.
High flow engine purge is enabled.
Yes.
Deluge is activated.
Hopefully we get another shot closer in here. There we go. Digital zoom. I wonder if they have a problem with their pad cameras. There we go.
T-minus 20 seconds and counting.
Come on, baby.
T-minus
There you
10,
go, baby.
9, 8, 7, 6, 5, 4, 3, 2.
Yes! I love how quickly it just...
Stage 1 propulsion is nominal.
Rocket Lab has some of the best audio. That is amazing. Hopefully we get a booster cam
Entering
going.
stage 1 burnout detect mode.
And we have liftoff of Electron from Rocket Lab Launch Complex 1. We're just 50 seconds into flight, and you heard the call out on comms there that the mission is continuing nominally. So Electron will approach max Q along its trajectory, otherwise known as maximum aerodynamic pressure.
Hopefully that camera, it just has a little bit of ice on it, and hopefully that goes away by the time they do re-entry.
Approaching maximum dynamic pressure. Past maximum dynamic pressure.
You can actually see that little gas thruster right in front of the camera there.
And there goes the call from our operator on console. Electron has cleared max Q. Propulsion is continuing to look good on the path to orbit.
Wow. Go, baby, go.
Stage 1 guidance is nominal.
Yes. This is so awesome.
Coming up next in the mission timeline is main engine cutoff, also known as MECO, as Electron's Rutherford engines power down so that the first and second stages of the vehicle can separate cleanly. Following that, the vacuum optimized engine on the second stage will ignite to carry the satellites on board further into space, while Electron's booster will begin to fall back to Earth, marking the start of our recovery attempt. The team on the recovery vessel will now be furiously tracking its return telemetry.
So, let's see here. I'm going to make sure that we'll be providing booster telemetry if they don't. I'm going to make sure I'm clearing theirs.
MECO confirmed.
Staging.
Yes.
Stage to ignition.
All right.
Recovery telemetry nominal.
Flight analyst, recovery LDN mission cord, execute sequence 53, stage 1 recovery operations.
Computing landing zone.
Okay, so we actually have telemetry up for you guys.
MECO is confirmed, and so too is the startup of the second stage Rutherford engine. With the separation of stage 1 and 2 complete, we'll try and stick with both views as long as we have them. The trajectories are looking good so far while we're awaiting fairing separation.
I really hope we get footage from the booster. There's fairings.
Fairing separation.
Sweet.
And there goes the fairing, and welcome to space, Mr. Noam Chomsky.
That's awesome.
Stage 2 propulsion is nominal.
So right now you'll notice the booster is at 0 G. There's 0 G forces because it's literally just coasting. Is that our booster camera? I can't tell. It's just so static looking.
If you're just tuning into the broadcast for our 16th Electron launch, we've successfully lifted off the pad at LC1 in New Zealand and have had a successful MECO, stage separation and stage 2 ignition. Electron's second stage burn is in progress as we hit 4 minutes and 17 seconds into flight.
The first stage very well might be higher than the second stage, by the way. Because sometimes they loft it up.
discharge nominal.
And sometimes you even will point down because you're just trying to get that horizontal velocity going. In Kerbal Space Program, have to do this all the time in order to circularize
Stage 1 apogee.
Stage 1 apogee. So let's see how Declan's data is doing.
Stage 2 guidance is nominal.
It's going up a little bit still.
Kilometers and speed is 1 point.
A couple of months ago, some of you may remember we conducted the maiden flight of our Photon satellite, which we called First Light, during our 14th launch. The kick stage, which you can see Mr. Noam Chomsky mounted to here, forms the basis of our Photon satellites. By offering launches and satellites as a bundled service, we make it easier for small satellite operators to get to space, removing the need for them to source satellite, launch, and ground stations separately.
So, friendly reminder, the telemetry is very experimental, and as a matter of fact, it looks like we might have a little problem with our G-force telemetry.
Stage 2 guidance still nominal. 200 seconds remaining.
So it shouldn't be experiencing any G-forces at this point, right? It's not decelerating at all.
Just a quick update for you all here. Electron's second stage burn continues nominally at a velocity of 14,000 kilometers per hour and an altitude of 190 kilometers. And it looks like we've still got visual of stage reentry as well, and it feels good to be back in space.
Oh, there we go. Look at this. Look at that. Now remember, it's going to be important that the first stage remains pointing exactly engines first, since that's where all the heat shielding is on the booster. That's where...
We're now at T plus 6 minutes and 8 seconds into flight, and both our second stage burn and first stage booster re-entry are looking stable. Next up will be battery hot swap to continue supplying power to the second stage engine and systems. Let's listen in for that call.
AFT is saved.
Come on. The first stage booster shot seems to have frozen a little bit. It might be experiencing a decent amount of
Stage 2
plasma now.
propulsion is nominal.
Remember, it's going to re-enter without...
Stage 1 re-entry.
Without any...
We've had battery hot swap confirmation, and we're about a minute and a half away from when we expect Stage 1's drogue chute to deploy. The ride is going to get a little bumpy on the way back down, with the booster reaching several times the speed of sound on its fall back to Earth.
Hopefully we get feed soon. Watch how quickly it's decelerating now that it's...
A reminder that we'll stick with the video feed as long as we can, but we do expect to lose it soon.
I wonder if I remember, he said, what did he say, 15,000 meters for drogue should deploy, something like that. I think I heard Peter mention it in a press
And as
conference
expected,
recently.
it looks like we've lost video connection to Electron's booster there. We should expect the first stage's main parachute to deploy at about 8 minutes and 44 seconds into the mission. If we get that confirmation while we're still on the air, we'll be sure to share it with you. Otherwise, check in on our social media channels for further updates when we end the broadcast. Now let's listen in for the call while we wait for Stage 2 separation.
Guidance is in terminal, 20 seconds remaining.
We'll see here. Nothing on that first stage yet.
Seeker confirmed.
Nominal transfer orbit.
There we go. That's what's important there, guys. No, Malone.
And as you just heard from the team in Mission Control, the engine on Electron's second stage has shut down and the kick stage has separated. So Noam Chomsky finally gets his day in space. In approximately 45 minutes or so, the payloads will be deployed to their precise locations using our innovative kick stage. So here's a quick rundown of how this additional stage works. Electron's second stage takes us to an elliptical orbit where the kick stage then separates. From here, the 3D printed Curie engine on Electron ignites to propel the stage and its payloads to a circular orbit for deployment. Using a cold gas reaction control system, or RCS, the kick stage accurately points itself to deploy each satellite to a precise and individual orbit, even on rideshare missions with multiple satellites like this one. Once the satellites are deployed, the Curie engine reignites, propelling the kick stage to a lower orbit where it will be dragged into the Earth's atmosphere faster, leaving behind no space junk in orbit.
I hope we hear about this. So we're going to remove our telemetry since we don't know anything about how it actually did. So let's see. I think they're waiting to see if there's anything back from it. Probably waiting to hear from the recovery team. Look at everyone. So Peter is kind of in the back row there, curly hair, third from the right, fourth from the left. So I'm kind of paying attention to him to see if he's getting any numbers or if there's any reaction about whether or not they had a main chutes deploy or anything. Oh, the chutes did deploy. The chutes did deploy. According to Rocket Lab's Twitter, the chutes deployed, everybody. Okay. That's awesome. Both the drogue and mains.
We've just had confirmation of successful drogue shoot and main shoot deploy. We can't wait to share we can't wait to share these photos of recovery in the coming days. So with that, we're going to end the launch broadcast here ahead of that final sequence. We'll be sure to let you know as soon as we can about our recovery efforts and of course payload deployment. Thank you once again to our customers for choosing to launch on Electron, and thank you to each and every one of you for tuning in to watch this very special mission. I'm Ariana Ryan.
And I'm Max Bunsey, and this is Rocket Lab Mission Control, signing off.
Wow. Wow. So, guys, it sounds like they did it. I mean, it sounds like... Wow. That's unbelievable. So hopefully we see some footage from that really soon. Peter, I'm sorry, my friend. I hope you have a hat made out of chocolate or a hat made out of like something delicious. Better be shopping around for those salsa hats, you know, like a tortilla hat or something, because Peter Beck, it's hat eating time, my friend. Yeah. Get that hat ready. Holy cow. Okay, so hopefully it splashed down successfully. Hopefully they can actually recover it from the water. See how it did. Oh, man. Wow. So I did see a really good question in chat. Why don't they use grid fins? So the grid fins are not very effective in the very upper atmosphere. The parts where you really have to do the precise steering to make sure that the booster's not doing much. There's not a lot of atmosphere. Also, the grid fins are in the wake. When you're going at supersonic, hypersonic, especially hypersonic velocities, the bow shock, the wake of the thing, the wake from the front of the vehicle ends up that, you know, almost all of that is the grid fins are entirely in the wake. That's why you don't want to put like an air brake up at the top of the interstage or something, because it's not the right place for it. If you want an air brake for something re-entering at that speed, you actually want it at the base where it actually can be in the airstream. Otherwise, it's actually almost entirely out of the airstream, things that are at the top for that regime, for that part. And for that part, that's when they really need to control with the little gas thrusters. So the gas thrusters keep them pointed during that region. The grid fins don't really gain too much authority until after the vehicle slowed down and gone in, you know, using the reentry burn. After the reentry burn, then the Falcon 9, then you see those grid fins start to do more and more and actually have some bite. But I'm not going to say they're useless before that, but they're probably they're not worth their weight, you know? Yeah. So let's see here. I'm confusing people. Wait, why? Yeah, I don't know. Leo says that. So remember, our telemetry on screen, everyone, if you're watching, our telemetry on screen was completely a simulation base from Flight Club. Declan it was a very experimental. So our data may have been completely off. It was in no way linked to the mission. It was all based on data of an approximate flight plan that Declan Murphy came up with. Declan does amazing work, but no one can really predict it until it happens. So we'll have to see and hear back from then. But splashdown of Electron, first stage confirmed. Recovery ops are on the way. Okay. Okay, Rocket Lab. I see you, Rocket Lab. Holy cow. That is unreal on their first freaking attempt. Hold on. I got to share this with you guys. That is unbelievable. Check this out. Splashdown of Electron's first stage confirmed. Recovery ops are underway and we'll bring you more soon. Everyone, let's just... If you're at home alone, I don't care where you are, just just applaud for tonight. This is a fun night that we all got to witness together. You know, this is not only did they recover a booster on their first try. Again, remember, this is not with the helicopter yet. They are not ready to add the complication, the human life factor of a helicopter quite yet. They're just seeing if it can survive reentry and splashdown, and then they'll see how the booster is and see if it's worth. Don't forget, a helicopter is going to cost a lot of money to go out there and catch. They'll find out if it's worth trying to catch it. You know, if this thing comes back just absolutely in terrible condition, you know, if they need to do more engineering, they can save several $100,000 probably just by not trying to catch it with a helicopter. So we'll see, you know, if they don't think they can refly it or have a path forward to refly, then they probably won't try catching it until that is an option. So yeah, that is unbelievable. I am over the moon right now. And I am over the moon for you guys, because it means a lot to me that you guys came out and just reaffirmed that there's good people out there. Again, all of tonight's Super Chat, the proceeds from the Super Chat will all be going to the same charity that Rocket Lab and that Gabe Newell from Valve is donating to, which is the Starship Hospital in Auckland, New Zealand. So Starship's Children's Health. I think it's hilarious that it's called Starship too. So I will be donating all of these Super Chats here tonight, all the proceeds. And because YouTube takes 30%, I will also be donating 1,000 of my personal dollars to try to offset some of that 30% from YouTube. And I will be posting receipts to have full transparency with you guys. So, you know, I'm not just saying it's going to charity and then it's just secretly going to Tim's Starship Fund. So what an awesome night, guys. Seriously, this is the kind of night that we're rounding the corner. I think the pandemic's coming up on an end. You know, we have Rocket Lab recovering boosters. We have, just so many big changes. We have Starship coming up for serial number 8 soon. We can be excited, people. It's time to get out from under your rock soon and put on your party hat, because it's time. That's so incredible. So if I were you guys, I would be tuned in to Rocket Labs. Oh, did I not send that tweet out? What? It doesn't say I retweeted it. Did I retweet it? I don't know. Doesn't matter. If I were you guys, I'd make sure you're following Rocket Lab's Twitter, see if they get updates. I'm going to head out of here soon. And again, just thank you guys so much for tuning in here tonight, but also more importantly for having tuned in to Rocket Lab's live stream as well too. So, Shane, yeah, we'll probably see the chutes deploy and we'll see footage from them from the reentry. I'm sure they're going to be really excited to show that off. So again, I think our best bet would be staying tuned on Twitter. Forrest, nope. All of tonight's, there's no beer funds or there's no sending Tim to Mars funds here tonight. All of this tonight is going straight back to a charity. So, no, my secret Starship fund is not me going to Mars or even on Starship. The Tim Starship fund would be me going down to see Starship. That's different. I'm not going to Mars. You're not getting me to go to Mars. You all know this. You can't do it. Yeah. I'm really excited. What a great night, guys. I just really, really appreciate all of you guys tuning in here, watching live with me as well. So, Brant wants to know where you can get a hat like mine. I'm sure you can get it on Rocket Lab's website. I got it from Rocket Lab. I don't remember, but, yeah. All right, guys, I think I'm going to go ahead and, wrap things up here with you guys. Again, stay tuned because the Starship the SN8 is pretty imminent. It might be next week. It might be early next week. Guys, here's the deal. Between me and you, it seems like there's rumors swirling that they're either maybe going to be repairing the pad and things like that and doing a small upgrade and maybe flying in like once that's all done in a week or 2 or 3 or whatever it takes, or they might just be launching relatively soon and just letting Starship do the majority of the demolition for the pad. Who knows at this point? You never know with SpaceX. So there's a small chance I might be leaving ASAP to get down to SN8. We'll see if we'll get answers from Elon. That's always the key, is getting answers from Elon. So, I guess, hey, we're here. We're 1,000 away from 800,000 subs. Wait, 1,000 away? No, isn't it 10K away from 800? I think I'm 10,000 away from 800,000. I'm not even. Oh. Huh. Did I just. Wow. Okay. Huh. Okay, I guess I'm only 1,000 subscribers away from 100,000. That's exciting. That's really fun. Thank you guys. So yeah, so that's awesome. Maybe that'll happen here really soon. Maybe by the end of the weekend or something. That's great news. Thank you guys. So thank you guys all for those of you that are subscribed and all that stuff. Don't forget, I will be having. Now listen. Here's the deal. I'm in the middle of essentially making a documentary right now. And I mean that. You've seen my long videos. You know how in depth I like to go into things. I am in the wormhole of all wormholes of wormholes of wormholes, which is Soviet engine rocket history. I'm doing an entire breakdown of every engine basically ever built from the Soviet Union, former Soviet Union, which also helps include Ukraine and Russia and all the other scientists from former Soviet republics. I'm getting into deeper rabbit holes than I ever thought possible, so I'm adding a whole new section in the script, by the way. Discord, sorry, and those of you patron members, sorry, but I actually am adding a whole new section that's just like the pre-history, going from how we got from the V2's A4 rocket engine into the RD-100s, the RD-103s, 105, trying to attempt the RD-110, but also going down the KS-50 into the ED-140, which is the basis of every single orbital rocket ever to come from the Soviet Union. It is unbelievable. Yeah, I think I'm at 25 pages now. It's going to be incredible. I can't wait. So get ready for that, everyone. If you're listening right now, you are going to have to you're going to have to get in the most comfortable chair of your life. But the good news is we're drawing out a whole family tree for you guys so you can actually make sense of the crazy history of the Soviet space program. I'm really, really, really excited for this one. Yeah, it's going to be nuts. It'll probably be a good hour, 15, hour and a half long. I might even shoot it a little bit differently so it is more of like an actual documentary feel. I might not even shoot in the studio. I might shoot it like, I could shoot. I wish it was safe to travel to Russia right now, because if it was safe to travel, I would fly to Russia and I would shoot all of this in front of hardware. I think that'd be pretty darn awesome. But yeah, I'm turning into like the Dan Carlin, the hardcore history, where it's like, I don't want to not know the answers to something. I want to know it all. Give me everything. Like I don't want to skip over chapters. You guys can do that, but I don't want to. You can skip through on YouTube all you want. I don't care. I want to learn it all for myself so that I have the context to know kind of how the development of all this stuff happened. So I can't wait. I green screen it. Yeah, I'm just going to green screen the whole thing. So I'm sitting in front of spaceflight hardware. Oh, I love it. All right, guys. That's going to do it for me. Again, thank you guys so much to all of you that donated tonight to the Starship Children's Hospital in Auckland, New Zealand. Again, congratulations to my friends at Rocket Lab. You guys are incredible. So inspired by what you guys are doing. We're all so proud of you. So, all right, guys, that's going to do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people. Goodbye, everybody.